Okay, welcome back. What we want to look at today is motor characteristics. Now, all I'm going to do is to take you through some of the types of motors and their relevant characteristics. Now, I'm not going to be reading this out to you in full. This is for you to read for yourselves. Now, this supports additional information which I've already given you in one or two of the videos in regards to motors. Okay? All I'm doing here now is to expand and to recap some of the sessions which I've done. So DC motors are divided into three classes, designated according to the method of connecting the armature and the field windings as shunt, series, and compound wound. Here we're then going to tell you how the shunt wound motors, this type of motor runs practically constant speed regardless of the load. Okay, and it tells you here the type of motors, where they can be used, the circumstances under which they can be used, and how they may be applied in certain circumstances. Now again, you need to read this for yourselves, extract the information, make it your own. Okay, that's what it is there for. And here you have the shunt motor is able to operate with RPM control while it is at high speed. So with this type of motor here, you can control the speed even though it's running at high speed. Okay. So let me just go back for a second, just make sure that. Okay, just make sure that it's in frame and I haven't missed anything out. Okay. Okay. Let me just take a closer peek at that. Okay. Okay. And here you have series wound DC motors. Now again, read the information so you understand the concepts behind it and how it works and where it can be used and why it is used. Okay. Knowledge is power, and the more information you have available to your own imagination or application, is the more you can use it in your own assignments and in your own work. And when you're talking to someone, giving an explanation, you know what you're talking about, hopefully. And again, I'm just going to bring this in closer to you to see. Look at how the series field is in series with your bush and the armature. Okay. Now I recognize where an armature is used and a rotor is used. We get to know which is which and which in what situation they're being applied in. Okay, that is for you to find out and to know what you're reading. Okay. And here we are. Now here you have compound wound DC motors, a combination of the shunt wound and series wound types. Okay, and here you have your diagrams. Now draw these diagrams out. So let me go in a little bit to make sure we get it in full frame. Okay, so you can then identify which is which simply by seeing it on another diagram, etc. Normally they may well appear on some schematics. Let me just go back down, make sure that we have it in frame, that it is visible to you in full. Okay. Yes, good. Okay, good. And here we have AC motors. Pardon me. Excuse me. Okay, let me just go back a little bit so we have it in frame in full. Okay. And I'll take it back a little bit slowly. Now remember, you can pause the video so you can read the information. Okay. But I know you guys think that you could do things quick. You know, it doesn't always work like that. And again, single phase induction motors, know where they work, know where they are used, know their handling capacity. And here you have synchronous motors. Now get to know what synchronous means, okay, and get to know what you're talking about when you refer to slip. Okay, because if a motor doesn't have some degree of slip, it means that it is going to be stationary, it will not move. And again, just to find that, I could be wrong when I've said that, but again, that is for you to find out. Let's come back, make sure we get it into frame in full. Okay. Now check this formula, make sure that it tallies with information in your electrical principles book, especially in those calculations you may well see in some textbooks. Make sure that your synchronous speed calculation formula is correct. Check, check, check. Safety, safety, safety. Every time. And here's your motor, just try to show you briefly in relation to synchronous speed and revs per minute that the shaft will be rotating in given revs per minute, but the synchronous speed is created by the stator field, which never quite catches up. So you have some degree of slip, always have. Okay. Right, I hope you found that useful. Okay. I have a good day, and bye for now.